All right, this is our last section for radicals. This one we're going to be dividing radicals. Another way to say that is rationalizing. And then we're also going to raise some radicals to a power. So here we go. First, we're going to start off with rationalizing and dividing. So there's just two rules you have to follow, okay? You cannot have any radicals in the denominator, and no radicand can be a fraction. So I'm going to show you what to do when this happens for both cases. So on case number one, I see a radical in the denominator. So what you're going to want to do is you're going to want to multiply by the number 1, but the way we're going to write the number 1 is related to the denominator, okay? Yes, that is simply the number 1. Radical b over radical b is 1. Any number over itself is the number 1, okay? 10 over 10 is 1. So now we're just going to multiply straight across, which you already were taught. So a times radical b is just a radical b. Radical b times radical b is just b, okay? You're probably wondering, why is it just b? Well, what is b times b? It's b squared. But then what's the square root of b squared? Well, if you expand it and you circle the pairs, it's just b, okay? So that's how you get that. And that's it. Now you've gotten rid of the radical in the denominator. That's how you should display your answer. Let's look at case number 2. We have a fraction that is a radicand. So the first thing you want to do is separate the x and the y like so. So these are exactly the same. It's a different way you can write the first one, okay? Now you got to go back and realize, hey, I have a radical in the denominator, so I'm going to multiply by radical y over radical y. Now multiply the numerators. Radical x times radical y is radical xy over radical y times radical y is just y. And that would be it. So let's try some examples now with some actual numbers and variables together. So first one, I see 5 over radical 3. So I'm going to multiply by radical 3 over radical 3. On the top, I'm going to get 5 radical 3 over 3. And there's my answer. Okay, let's try the second one. I see a radical, so I'm going to multiply by radical 2 over radical 2. I get 6 radical 2 over 2. Now what you need to realize here is that you can simplify these right here. 2 goes into 6 evenly, okay? And those are just, they're normal numbers, just like you would simplify any fraction. So your final answer is going to be 3 radical 2 for this one. Okay, let's try the next one. The next one, I'm going to multiply similarly like the one we just did. By radical 2 over radical 2. I get radical 6 on top, and I get 2 on bottom. You always want to ask yourself, can you simplify? Okay, be sure to simplify. Obviously, you can't with that one, so this is going to be our answer. Okay. Next one, I'm going to multiply by radical 3 over radical 3. You should be getting the hang of this. On the numerator, I'm going to get 2 radical 15. On the denominator, I already have a 3, and then you have to realize what radical 3 times radical 3 is, and that's a 3, which this right here is going to just simply be 2 radical 15 over 9. And you can't simplify anything else, so we're going to leave it as is. Okay, let's check this next one. Now here's something that I want to tell you. In this one, whenever you can simplify anything in the radicands firsthand, then do that. For instance, this A and this A cancel out. Those are both radicands, and you're allowed to cancel out. So really what this is radical 5 over radical 3b. Okay, so I'm going to put a little side note, and you should too, write simplify first. Exclamation point, okay? Right there in that one. So you can simplify those A's out. So now I'm going to multiply by radical 3b over radical 3b. Okay, and then down here I'm going to get radical 15b over just 3b. And that's it. You can't simplify anything else, so that's going to be my final answer. All right, let's go to the next one. The next one, I see a radical in the denominator, a fraction in the radicand as a radicand. And just like you wrote down here, can you simplify first? Okay, as you're looking at that fraction, you should realize that you can. Both of those can be simplified. 2 goes into 8 4 times, 2 goes into that 7 times. So really what you have is 7 radical 4 over 7, okay? So now let's do what we said earlier. You have a fraction as a radicand, so I want you to separate it like this, okay? Again, simplify first. What do you notice you can simplify? When you can simplify first, it makes life a little bit easier and you don't have to simplify as much as the end, okay? But what is the square root of 4? Y'all should realize, oh, that's just a 2. So then you have this. Now you still have a radical in the denominator. So what do we do next? We need to multiply by radical 7 over radical 7. Okay, I still have a 7 out in front. The numerator is going to be 2 radical 7 over 7. Okay, you should realize now that, oh, if I have a 7 here and a 7 here, those are going to cancel out. If you don't realize that, pretend this is a fraction, put it over 1. Okay, you can multiply it out if you want. 7 times 2 is 14 over 7. You see how it's going to reduce back to 2. So there's my final answer, 2 radical 7. Box your answer. All right, let's look at this last one. Ask yourself, can you simplify first? And you should realize that you can. Okay, so look at this. Look at that 8. Look at these A's right here. You can simplify those because those are all under the radical, so you can simplify that. By the way, radical 8 is just simply 2 radical 2. So radical 8 is 2 radical 2. And then you need to remember from algebra 1 that this cancels out. You just subtract the exponent. 6 minus 4 is 2. So this is simply just a squared up top. All right, so I simplified the 8 to 2 radical 2. I have an a squared in the radical. Well, you should know what the square root of a squared is. What is that? It's just simply a. So on the top, I'm going to have 2a radical 2. Okay, you did a lot of simplifying here. On the bottom, can you simplify the b to the 3rd power? Yes, half of 3 is 1 1/2. So a b is going to come out, and then you just have radical 3b. Okay, so let's say you forgot to simplify at the beginning and you just wanted to straight multiply by radical 3a to the 4th b cubed. That's fine too. You'll just have to be sure to simplify in the end. Okay. All right, so now I'm going to multiply by only the radical that's in the bottom, which is radical 3b. Okay, radical 3b over radical 3b. So that way we can get rid of the radical that's in the denominator. So I'm going to multiply. I'm going to have 2a on top. I'm going to have radical 6b on top over. I'm going to have a b, and then radical 3b is just 3b times radical 3b times radical 3b is just 3b. All right. I only have one last thing to simplify. I can multiply those two. So here's my final answer. It's going to be 2a radical 6b all over 3b squared. And there's really nothing else you can simplify. And that's your final answer. All right, so that's dividing radicals right there. Okay, let's look at the next slide. Now we're going to raise radicals to a power. Okay, so there's 2 ways you can do this when you simplify radicals raised to a power. Option 1, you can expand the radical and then just simply multiply. Option 2 is you can distribute the exponent and then simplify after that. Okay, so I'm going to show you both ways here. So first example, 4 radical 12 squared. And by the way, you can simplify first if you want to, but in this case, I'm going to show you that I'm not going to choose to do that. So here we go. So when you expand this, you're going to write it as 4 radical 12 times 4 radical 12, because that's what squared means. So now it just becomes a multiplication problem like you have already learned. 4 times 4 is 16. Radical 12 times radical 12 is just 12. So now you just have to put 16 times 12 in your calculator. So what is 16 times 12? Let me grab my calculator. 16 times 12 is 192. And there's your answer, okay, when you expand it. Now let me show you what it means to distribute, okay? When you distribute, you imagine this squared being distributed to each term inside. So there's a little imaginary 1 on these, right? And so 1 times 2 is just 2, so 4 squared and radical 12 squared, okay? 4 squared is 16, radical 12 squared is just 12. And we still get that 192, okay? So the red is distributing, the blue is expanding. Okay, let's try this next one. Let's expand it first, so you know that that is an option. So we're going to do 5 radical 18 times 5 radical 18 times 5 radical 18. Well, what are you going to do? You're going to multiply 5 times 5 times 5, right? So 5 times 5 times 5 is 125. And then you should know that the square root of 18 times the square root of 18 is just 18. So I'm going to write 18. And then I have a radical 18 still left over here. Okay, so let's go ahead and multiply 125 times 18. I'm going to get 2,250 radical 18. Now you need to ask yourself, can you simplify the 18? Yes, you can. I'm going to come over here and do the little tree. 9 and 2, 3 and 3, underline. Okay. So this right here, the 3 is going to join the 2,250. So my final answer is going to be 6,750 radical 2. There's your answer. Okay. Now let me show you the distributing way. So you have another option. So you're going to distribute the 3 to both of those. So you get 5 cubed. And then you get radical 18 to the 3rd power. Okay. Now think about it. Just it's kind of the same way as, you know, when you took half of the exponents. Half of 3 is 1 and a half. You see that? So you just have 5 cubed times 18 times radical 18. So that equals 2,250 radical 18. Remember, you can simplify the 18 just like we did a second ago. 3 is going to join that, and there's our answer, 6,750 radical 2. Okay, so there's 2 ways you can do this. All right, let's try 2 more examples. So the 5, we're going to distribute. Okay, I'm going to do the distributive way this time around instead of expanding and writing that out 5 times. So I'm going to distribute the 5, so I get 3 to the 5th radical 24x to the 5th. Okay, what is half of 5? 2 and a half. And then I still have 3 to the 5th out in front. Okay, and then you want to distribute over here as well. Okay, so you have 3 to the 5th, 24 squared, x squared, radical 24x. Okay, now you can simplify that 24 to a 4 and a 6, circle, underline. I'm going to bring out the 2 over there, and a 6 is going to go underneath, and then I still have that x. So my final answer, I'm going to do a lot of multiplying here. So I have 3 to the 5th. So I'm going to put that in my calculator. 3 to the 5th is 243. And then times 24 squared now makes that 139,000. Don't forget you're joining the 2, so I'm going to hit times 2. So your coefficient is 279,936. Oops, don't forget about what we had. 279,936. We already had an x squared out there, so I need to write that again. And then radical 6x. And there's your answer right there. Okay, last one for these notes. Okay, we have raised to the 6th power. The exponent's getting kind of big, so I'm not going to expand it again. I'm going to distribute. So this is going to be 3 to the 6th, and then radical 8x to the 5th raised to the 6th. Okay, now you have a radical to the 6th, so take half of 6, which is 3. Okay, if you don't understand that, imagine writing this out 6 times, and then we'll go ahead and take the time to do that. See how we're writing, expanding it. 1, 2, 3, 4, 5, 6. Well, there's a pair, there's a pair, and there's a pair. How many pairs do we have? 3. Okay, so now I still need to distribute the 3 to each one. So I have 3 to the 6th, 8 to the 3rd, and x to the 15th. Okay, you need to remember from algebra 1 that you multiply these exponents right here, 5 times 3. All right, and I'm almost done with my final answer. I got to put these in the calculator. 3 raised to the 6th power is 729. 8 to the 3rd power is 512. X to the 15th. So 729 times 512. My final answer is going to look like this. This is a big number, so I'm going to write it right here. 373,248 x to the 15th. And that is it.